Today, we're diving into some really cool research on large reasoning models,
Oh, yeah.
specifically how they handle those knowledge gaps,
Yeah.
those frustrating knowledge gaps that can just totally derail a reasoning process.
Uh,
It's like you're solving a complex equation and you suddenly realize,
oh,
oh, I need a specific formula for this,
right.
and I don't have it.
Yeah.
That's kind of the challenge that researchers are tackling with Search 01.
Right.
It's a new framework, and it's designed to give these LRMs access to external knowledge
Yeah.
and then the ability to really use it effectively.
It's super interesting.
Yeah.
It's not just like throwing a bunch of data at the model. It's
Right.
like giving it the tools to actually search strategically
Right.
and then refine that information
Yeah.
before it even uses it in its reasoning.
Exactly. It's not just about retrieving it, it's about integrating it
Yeah.
in a smart way.
Mm-hmm.
And what's really neat is that they're actually comparing 3 different approaches.
Yeah.
So there's that standard LRM reasoning.
Yeah. On its own. We can call it vanilla reasoning.
Yeah.
Then there's agentic RAG, where the model itself gets to decide when it needs to go search for some information. And then, of course, there's Search 01 with that really unique reason in documents module.
Yeah, and I think one of the things that they found in the research is that even these advanced models,
Oh, yeah.
even the really sophisticated ones, they struggle with uncertainty
Right.
when they're dealing with something new.
Totally.
So when they looked at the language that LRMs use, when they're
Wow.
tackling these really hard problems,
Yeah.
they found a lot of perhaps, wait, and likely.
Oh.
And actually, figure 1,
Yeah.
it shows that perhaps shows up like 30 times on average
Wow, that's a lot.
per reasoning process for the really tough problem.
Yeah.
So it seems like the model is kind of second-guessing itself.
Yeah, it's a lot of hedging
It is.
for such a supposedly brilliant AI.
Yeah.
And I can definitely see how all that uncertainty could lead to wrong answers. Totally.
So how do these different approaches try to tackle that problem?
Right.
Let's start with that vanilla reasoning,
Okay.
where the model can only use what it already knows.
Right. So imagine you're asking the LRM to calculate the number of carbon atoms
Okay.
in the final product of this multi-step chemical reaction
All right.
without external resources like a chemical database.
Mm-hmm.
It's probably going to get stuck
Right.
or make the wrong assumptions.
Yeah, it's like trying to bake a cake without knowing the recipe,
Exactly.
the ingredients.
Yeah, it's not going to go well.
So how does agentic URIM improve on that?
Right.
It's like we're giving it access to all those cookbooks now, right?
Exactly. So with agentic RAG, the LRM can decide for itself when to search for information.
Okay.
Like a researcher who's hitting a roadblock
Yeah.
and they need to look up a study.
Uh-huh.
It adds a bit of autonomy to the process.
It sounds a lot more efficient
It is.
than just, throwing tons of information at the model.
Yeah.
But there are still limitations to this approach, right?
There are, because even with that ability to search, agentic RAG can get overloaded.
Yeah, maybe
But just how much information is out there?
too much information.
Too much. Yeah, imagine you search for the structure of this really complex compound
Mhm.
and you get back pages and pages of dense documents.
Yeah.
Even for a machine, that's information overload.
Yeah, it's like drinking from a fire hose.
Exactly.
So how does Search 01 deal with that fire hose?
So this is where the Reason in Documents module comes in.
Okay.
It's almost like having a really smart research assistant
Right.
that can not only find the relevant information,
Mhm.
but actually boil it down to the key points
Yeah.
and present them in a way that works with the model's reasoning.
Okay, so it's not just finding the information. It's
Yeah.
like understanding it
Yes.
and actually using it correctly.
Exactly.
Can you give me a real example of that?
Sure. So let's go back to that chemical reaction problem.
Yeah.
Let's say the model needs to know the structure of trans-cinnamaldehyde
Mhm.
to move forward.
Okay.
So with Search 01, it wouldn't just pull a bunch of documents about
Yeah.
the compound.
Yeah.
The Reason in Documents module would analyze all of those documents,
Okay.
find the exact information needed,
Mm-hmm.
which might be the chemical structure
Uh-huh.
or some property,
Right.
and then extract it in a concise way.
So it's like it's creating a little targeted summary
It is.
of all that research,
Exactly.
pulling out just what's needed.
Yeah.
And then how does that information actually get back into the model's reasoning?
So then this refined information gets added into the model's reasoning.
Right.
Like adding a new equation to a system of equations.
Mhm.
It doesn't interrupt the flow, it just makes it better.
It enhances it.
Right.
That's really cool.
Yeah.
It's a 2-stage process.
Mhm.
So first, it makes that little intermediate reasoning sequence
Yes.
based on those documents. What is
Well-
happening there?
So essentially, it's making a summary for itself,
Okay.
picking out the key takeaways,
Yeah.
but in a way that's relevant to what it's working on right now.
It's doing it with a purpose,
Exactly.
not just reading for fun.
Right.
It's like it's creating its own study guide.
That's a good way to think about it.
All right. And then in that second stage,
Yeah.
it uses those mathematical representations
Yes.
to look at how all this new information
Right.
relates to what it already knew.
Exactly. It's mapping out those connections.
Oh, that's cool.
Yeah. And that helps it to figure out which information is most important
Okay.
and how to incorporate it smoothly.
Because it's using math, it can do that without messing everything up.
Exactly. It enhances the reasoning. It doesn't disrupt it.
I think that's a key point.
It is.
It's not just about having the information, it's about using it the right way.
Yeah.
And Search 01 seems to be doing that really well.
It does.
I'm really intrigued by this.
Mm-hmm.
Let's look at how it actually performs compared to the other approaches.
Okay. Welcome back to our deep dive on Search 01.
It's like we're giving LRMs a cheat sheet to the entire universe of information.
Yeah, but it's not just a cheat sheet.
Right.
It's more like we've given them a personal tutor
Yeah.
to guide them through all that information.
Yeah, we're not just throwing a textbook at
Exactly.
them.
We're giving
Yeah.
them the ability to really understand and apply what they're learning.
Exactly. And it's that Reason in Documents module
Yes.
that really sets Search 01 apart.
Right. It's not just about finding the right information. It's about knowing how to use it.
So we know that Search 01 beats vanilla reasoning and agentic RAG.
It does.
But how does this Reason in Documents module actually do its magic?
So it's a two-stage process.
Okay, remind me about that first stage again.
Sure. It's where Search 01 generates that intermediate reasoning sequence.
Oh, right, like a little summary of the key points.
Right. But it's more than just a summary.
Okay.
It's really about focusing on the information that's directly relevant to the problem the model's trying to solve.
So it's like a researcher highlighting the most important parts of a paper.
Exactly. It's about making sure the model is focusing on the right things.
Okay, that makes sense.
And that sets the stage for the second stage.
Where the math comes in.
Exactly.
It uses math to look at how all the new information connects
Right.
to what it already knew.
It's creating a map of knowledge, if you will.
That's a great way to put it.
And that map helps Search 01 figure out which pieces of information are most important
Okay,
and how to fit them together with its existing knowledge.
and because it's using math, it can do this without disrupting its reasoning.
Precisely. It's all about seamless integration,
Yeah.
enhancing the reasoning process, not derailing it.
This is all starting to sound a lot like critical thinking.
It is, isn't it?
It's like Search 01 is evaluating the information it's finding, making judgments about what's relevant and reliable.
And that's a really interesting aspect of this research.
It is. It makes you wonder about the future of AI.
It does.
If we can create systems that can think critically, what are the possibilities?
The possibilities are exciting, but we need to be cautious too.
Absolutely. We have to make sure we're developing and using these technologies responsibly.
Right. But let's get back to Search 01 and those impressive results.
Okay, so they tested it on more than just those multi-hop questions, right?
They did. They also looked at how it performed on those traditional reasoning tasks.
And how did it do?
It did remarkably well.
Let's dive into those findings. So we've been talking about Search 01 and this incredible Reason in Documents module.
Right. How it takes those retrieved documents and actually turns them into usable knowledge.
Yeah, and we saw how it outperformed both vanilla reasoning and agentic R.
Yeah. Those comparisons were really impressive.
Can you remind me what they found?
Well, on that GPQA dataset with those tough PhD-level science questions, Search 01 did 4.7% better on average
Wow.
than agentic R.
That's huge.
It is, especially considering how complex those questions are.
And it did that with fewer documents.
It did, even with just one relevant document.
Wow.
It beat out the other methods that use 10.
That's amazing.
It's really efficient.
It really shows how Search 01 isn't just finding information. It's actually understanding it and using it the right way.
And it wasn't just science questions.
Right. What about those math problems?
Yeah, they used the AMC 2023 dataset.
Okay, those middle school math competition ones.
Yep, and even there, Search 01 was way better than the other models.
So this isn't just about one specific type of problem.
No, it seems like Search 01 can handle different domains.
Yeah, maybe we're seeing a more general AI intelligence.
It's a really interesting possibility.
I mean, think about what we could do
Right.
if we had AI that could reason across all these different areas.
Yeah, we could see incredible breakthroughs in science and technology.
Imagine AI helping scientists make groundbreaking discoveries.
Or helping engineers design amazing new things.
Yeah, or even collaborating with artists.
The possibilities are really endless.
It's pretty exciting.
It is.
But we have to remember that with this power comes responsibility.
Absolutely. We need to make sure we're using this technology ethically.
Yeah, we have to think about potential biases in these systems.
Right, and make sure they benefit everyone.
Not just a select few.
We also need to be aware of how these systems could be misused.
That's a good point.
As AI gets smarter, we need stronger safeguards against malicious use.
So who is responsible for making sure all of that happens?
That's a big question.
It is. It's not just about the technology itself.
Right, it's a societal issue.
And we all need to be part of the conversation.
We need researchers, policymakers, and the public to all work together.
AI is a tool, and it's up to us to decide how we use it.
I think that's a great way to put it.
So as we wrap up our deep dive into Search 01,
Yeah.
let's all keep thinking about these questions.
Keep the conversation going.
The future of AI is in our hands.
Absolutely.
So thanks for joining us on this exploration of cutting-edge AI research.
It's been a pleasure.
Until next time, keep exploring and keep learning.